Okay, well, welcome, class. We're going to be talking now about calculating the present value of an amount of money, so that you can have a certain amount that you desire in the future. And we're going to also be using the tables to solve these particular problems. This is actually section 11.7 in your book. And just to give you kind of a big picture of how present value and future value work, what we've been looking at so far is compounding a certain amount of money that we've invested. And over a certain amount of time, we have what we call a compounded amount. Well, that compounded amount is the future value. So if I deposited or invested, $5,000 today, and I put it in for a certain amount of time with a certain interest rate, and when that time period ends, whatever the value of that $5,000 is then is its future value. So if I invest it today, that's the present value. And what I find in a few years after the interest has been accumulated is the future value, or the compounded amount. Well, future value, or excuse me, present value, is we're trying to find out, well, what is the present value of a future amount? So if I start with the future amount, like let's just say I want $500,000 in 10 years. How much do I need to invest today in order to have that in the future in 5 years or 10 years? So that's what we're going to be looking at. Is we're going to be starting with the finished amount of money that we hope to have or want to have in the future. So what do I need to put in today? What is the present value today of that money in the future? And that's what these problems focus on here in the rest of chapter 11. And this is actually all found, the chart you're going to use, or the tables you're going to use, is table 11.2, and it's the present value chart or table. And it takes a dollar and considers its present value. It gives you a dollar over different periods of times over different interest rate, and it gives you the present value of that dollar today. So that's its opposite. So they're all going to be under a dollar. They're all going to be percentages of a dollar, because they're all looking from a dollar in the future backwards. So it's interesting to consider, but we'll look at it together. So we'll start with this first problem here using the table. It says Charlie Wilson needs $5,000 in 8 years. Use table 11.2 to find out how much if he invests now at 6% interest, how much does he need to invest today to do that? And so that's what we're trying to find out. So we know he wants $5,000, and we know that it's going to be for 8 years. And we also know that it's going to be 6% interest, and it's going to be compounded semi-annually. So the same way that we were doing it with compound interest, we do it with the present value problems. The only difference is we're looking at what is the present value of the $5,000 8 years from now. So 8 years from now, it's going to be worth $5,000, but we're looking to find out, well, how much do I need to invest today to have $5,000 in the future? So what is the present value of $5,000 at these rates? So because it's semi-annual, I need to do the same thing. It's going to be times 2, so it's going to be 16 periods of compounding. And then my interest rate is also going to be divided by 2, because, again, an interest rate is over a year. And if I'm going to compound it twice in 1 year, it has to be divided. So that's going to be 3%. So I need to go to my present value chart in order to find the solution. And I'm going to show you the present value chart. And I'm going to have to come back and rewrite the problem, because it's going to erase everything when I do. But let me open that chart. Okay, so you are looking at the present value chart, and in the same way, I remembered what our periods were. They were 16 periods, and I also remembered what our interest rate was. Our interest rate was 3%, and so we're going to take that back to the problem we were just working on. But if you notice, this is the present value chart based off of $1, working backwards. So they're all under 1. Every single one of the factors is under 1, because 1 is what it's going to be worth at the end of that period of time and the interest. So the closest thing you're going to get to 1 is actually 1 period at 0.5% interest. As you can see, there is 999,502. And so that's the closest to $1 you're going to get on the $1 chart. But we use the same chart, of course, to figure out our table factor and to figure out how much the present value of a certain amount is in the future. So in the case of this particular problem we're looking at, we said it was going to be 16 periods. Remember, 8 years, but twice a year, so 16. And then it was going to be 6% interest a year, but going to be done twice a year. So I got to divide that in half. That's 3%. So I'm going to take the 16 and the 3%. Where those two come together is the value I'm going to write down. So I'm going to write it down so that I can finish my problem. So 0.62317. And I'm going to go back to the other screen. All right, as I mentioned, it was going to eliminate everything that we wrote down because I moved away, but 8 years, it's going to be 6% interest, semi-annual. And so again, we're going to need to divide or multiply the 8 years because we're going to 1 year, 8 years, but we're going to do it semi-annually. So that's 2 times a year. So that's going to be 16 periods. And then the 6% is per year, but we're going to do it twice a year. So we cut that in half to 3%. So it's going to be 16 at 3%. When I did the table factor, it was 0.62317. And all I would do at this point is multiply the 5,000 by 0.62317. And when I do that, I come out with $3,115.85. Now notice that value is lower than my original investment. Why is that? Because I'm not investing $5,000 today. I want $5,000 8 years from now at 6% interest. So how much do I need to put in today to get that $5,000? So what you will find in the present value problems is that your beginning amount, your amount will always be less than the amount you're multiplying. It'll always be less. So in this case, it's $3,115. If I put $115 in the bank today, in 8 years at 6% interest rate, I will have earned the $5,000. It will be worth $5,000. So you might say, well, how do I figure out which kind of problem I'm using? Remember, it's what they're telling you. He will need $5,000 in 8 years. So he doesn't need it today. That's what he wants in 8 years. So that's what you need to be looking for in these present value. And usually I'll give you a hint because I'll tell you which table that you need to be looking onto. And if it's the 11.2, that means it's the present value. They're looking at what is the present value today of that amount in the future. So looking at the next problem, maybe it'll make more sense if it's not yet, is Count Gustavo wants to renovate his castle in Bologna in 3 years. He wants to do it in 3 years, so that's the future. And he estimates the cost in 3 years to be $3 million. That's a lot of money. 3 years. And how much must Gustav invest now? So present value at 8% interest, compounded quarterly. Now quarterly is 4 times a year. And then he'll have the 3 million in 3 years. So quarterly is 4 times a year. So that means if the 8% is going to be figured, it's figured over a year, but I'm going to be compounding it 4 times a year, I would divide the 8% by 4, and that would come out to 2%. So every time I compound it in a year, I'm going to compound it 2%. And if the 3 years is compounded 4 times every year, I got to multiply 3 by 4. So 3 times 4 is 12. So I'm going to be looking for 12 compounding periods at 2% each on my table. So I'm not going to open the table again just because I don't want to have to erase everything I've done. So I'm just going to look at it here. I have it in my book. So I'm going to look at 12 periods and I'm going to go to 2%. And the value comes out to 0.78849. 0.78849. I would multiply the $3 million by that amount. Doing the math on that, the answer comes out to $2,365,470. So in order for Gustav to be able to renovate his castle with $3 million in 3 years, he needs to invest $2,365,470 today at 8% interest, and in 3 years, he will have the $3 million that he's hoping to get. All right, the next problem is calculate a new table factor in just the same way that we had to sometimes look for periods that were off the chart, like they were more than 25 because the chart only went up to 25. We have to sometimes create a new table factor based on how many periods in which we are going to be compounding. So for instance, this problem says that they have a present value of $8,500 if the interest is 6% interest compounded quarterly for 10 years. So 10 years compounded 4 times a year, that means it's going to be compounded 40 times, right? And that's going to be tough. Now, again, the 6% could be divided by 4. And that comes out to 0.5%. So you would have a 0.5% for everyone. And anyway, so we will, or 1.5%, sorry. 1.5% if I was to go to the chart. So if I was to go to the chart, I'd go to 1.5%, and then I would go to 40 times. Well, it doesn't have 40 times on the chart. It ends at 25. So what I would need to do, sorry about that, is I would need to probably divide that by 2 and look for 20. And I would write down the table factor for both 20 times. So 20 times at 1.5% is 0.74247. And remember, when I'm going to find a new table factor, let me double check that, 0.74247. When I'm going to find a new table factor, all I do is I multiply those two together and I get a new table factor. So if I go to 0.74247 times 0.74247 equals 0.551617. That is now my new table factor. And that is all the question is asking for. Calculate a new table factor. Now, if it wanted me to finish the problem, I would simply take the 8,500, I'd multiply it by 0.551617, and that amount would be $4,685.72. So again, how much would I have to invest today? What is the present value of 8,500 at 6% interest in 10 years compounded quarterly? The present value today of that is $4,685.72. So I was able to do the table factor. All right, so that's pretty much it for compound interest. I believe I wasn't going to do any more. Those were the 2 sections. There is a compound interest formula as well, also found in the book. And I'm not going to work out any problems on this, although I did on the compound interest. But I did include it in the if some of you are daring and want to try and use the formula, you're more than welcome to do it. I did not include it. I did include it, should I say, on the formula sheet. So it's really up to you if you want to venture and give it a shot. But it looks like this. It is present value equals, which is this, we were looking for a compound amount before. Present value equals the compound amount, which is the total, divided by 1 divided by interest with how many times it's been done. So if I was to take that last problem that we just did, the present value would be the compounded amount, which is 8,500, and that's going to be divided by 1 divided by the interest rate, which is 0.015. That was 1.5% at, we said it was 40. So that would be the formula filled out. And if I did the math on all of that, it would have came out to the 46, whatever it was, 52 or whatever it was in the last problem. So you can use the formula if you want. I'm not recommending it. I think you should just use the tables. And I think you'll be a lot more, in most cases, the students get them correct when they use the tables and they get them incorrect when they use the formula. So I highly recommend just use the formula. But anyway, the tables. So that's it for present value. That's all you need to know. It's very similar to compound, but this will be a separate video. Thanks again. I'll hopefully you guys get it. If you need help, you can always reach out to me. There's also YouTube videos below that show you how to do it as well on some present value problems. So I think I have one showing you how to use the formula and one how to just use the tables. So have a great week, everybody.